Hi, in this lesson, we're going to work with the metric system and dimensional analysis to complete unit conversions. So grab your calculator and some notes and follow along. So the metric system is, remember, the international system of units. It's a nice system because everything is related by the power of 10, and it's almost universally accepted, except, of course, the United States and a few other small countries do not use it for like common measurement. But we do have some things that are measured in metric, like track and swimming, our 2 liter soda bottles, some things like that. But we still pretty much stick with the old English system here in the United States. But in science, the United States has definitely gotten on board with using the international system of units, and that's why it's important for you to learn those. We also need to be able to know how the different units within the international system are related to each other so that we can use them to do conversions. And that's what we're going to work on today. Now, within the international system, there are base units, okay? Um, and those are things that are defined by a physical object, okay? Like they, have a platinum rod that is exactly a certain length. And then there are derived units that are basically gotten by a combination of different units like speed and volume. Speed being a distance unit and a time unit like meters per second. Let me show you how volume is derived from a different unit. So if I have a cube and it is 1 centimeter on every side, okay? The volume of the cube, remember, is length times width times height, or since they're all the same, we can just say side cubed. And so the volume of this cube would be 1 centimeter cubed, which is a cubic centimeter, okay? This quantity is equal to a milliliter. A milliliter is defined as a cubic centimeter. It is derived from an area of space defined by, being a cube that is 1 centimeter in every direction. So that's an important equality to know. If you had a larger cube and it was 10 centimeters on each side, 10 centimeters is the same thing as a decimeter. So we could just say that our cube is a decimeter on each side. Then the volume of this cube would be, okay, 1 decimeter cubed, or 1, cubic decimeter. And this quantity is equal to a liter. Let me show you why that is equal to a liter. If we did the volume and we did it in centimeters, it'd be 10 centimeters on each side cubed. 10 cubed is 1,000. 1,000 cubic centimeters. That's, remember that a cubic centimeter and a milliliter are the same thing. That's 1,000 milliliters. And milli, by definition, is 1/1000th of a liter. So if you have 1,000 of them, you have a liter. So this essentially gives us two equalities that we need to remember that are going to make our life a lot easier in chemistry. We need to remember that a cubic centimeter is the same as a milliliter, and that a cubic decimeter is the same thing as a liter. If you can remember those two, doing unit conversions with dimensional analysis is going to be much easier. So these are the metric prefixes that you need to know. Remember, you've got base units, which could be anything like, liters, meters, liters for volume, meters for distance, grams for mass, but it could be like seconds because you can have a millisecond. So, it could be anything. And then there are, prefixes for other metric units and then how they are related to the base. So, for example, if I have 1/10 of a meter. Okay, let's say the base that I'm going to talk about is a meter. If I have 1/10 of a meter, I have a decimeter, which we would abbreviate DM. And so 1 decimeter is, 1 times 10 to the negative 1, which is 1/10 of a meter. Okay, if I have a centimeter, that is 1/100th or 0.01 of a meter. So 1 centimeter is equal to 1/100th of a meter, and so on, with milli being 1/1000th, 0.001. And then there are other units in between milli and nano, but this is the only other one that you're going to need to use in this class. And if I have, for example, a nano, if I have a nanometer, then that is 1 times 10 to the negative 9 meters. Okay, these are conversions right here that are equalities that we're going to have to use in doing dimensional analysis. Much like we can say, hey, a foot is 12 inches, we can easily say, hey, a centimeter is 0.01 of a meter. And so they become equalities that we're going to use. Then you can take your base unit and you can combine them together. If I have 10 of my base units, okay, 1 times 10 to the first is 10. If I have 10 base units, that's a decameter. If I have 1 times 10 to the second, that's 100. If I have 100 meters or 100 base units, that's a hectometer. If I have 10 to the third, which is 1,000 of the base units, that's a kilometer, okay? And 10 to the sixth, that's a million. If I have a million of them, that would be what we would call a megameter. And there are, again, other units in between and beyond. There's other bigger ones and other smaller ones, but these are the ones that we have to know in this class this year. And if you know these values right here, which I think is pretty easy because you've got your base, and then you just go up by 1, 1, 2, 3, and then you skip 3 and go to 6, and then you go down 1, 2, 3 with a negative, and then you skip 6 of them and go to negative 9. You'll have the order. And then what a lot of students do is, come up with like a saying or something to help them memorize the order of the prefixes. So that is something that you have to know, and something that we're going to use in the lesson today. Okay. So dimensional analysis is just a way to do unit conversions. Okay. We're also going to use dimensional analysis later this year to solve problems. Dimensional analysis is great. Sometimes it's called the factor label method. It's great because of its simplicity. The top and the bottom of the factor have to be equal to each other, and you basically set up factors to cancel the units you don't want and work towards getting the units you do want. So these are things that I'd have you write in your notebook. You can pause this presentation on a quiz or a test. I will give you these. There are others that I won't give you. Like, I assume that you know that a yard is 3 feet and a foot is 12 inches, that, a day has 24 hours, even though I wish sometimes I had more, that, an hour is 60 minutes and a minute is 60 seconds. I'm going to assume that you know some of those, okay? So between these equalities right here and the equalities established by the metric prefixes, we are going to do some dimensional analysis problems. Now, here's an example of a dimensional analysis problem. Let's say a football field is 100 yards long, which we know it is, and you need to convert that into centimeters, okay? So in dimensional analysis, you set up a factor. Top and bottom of your factor have to be equal, and you set it up so that your units will divide out. So we know that a yard is 3 feet, okay? So you can see here that your units are going to divide out. We know then that a foot is 12 inches. And from the last slide, we know that an inch is 2.54 centimeters. So if it's set up in this fashion, you can see that the units divide out. Now the key to getting that to happen is that whatever the label is here, you want to put that on the bottom in the next step. And then the bottom and the top of your factor have to be equal. And then whatever the label is on the top, you want to put it on the bottom of the next step and convert into an equal unit. And so on until you get it into the unit that you want, in this case, centimeters. Now, when you solve this, you would take the 100, you would times by 3, times by 12, times by 2.54. This one doesn't have any numbers on the bottom except for 1, but if there's a number on the bottom, you need to divide by that. And when you do, you're going to get 9,144 centimeters. Now, you can do metric conversions the same way. Like, we've got 5 liters here. We can set up a factor, and we can go from liters to milliliters. Then you have to go back to the metric chart where 1 milliliter is equal to 0.001 liters. So you're going to divide by 0.001, and that's going to give you 5,000 milliliters. Now, I have a lot of students that have learned in other classes in the past to move the decimal. And I guess if you're doing a simple conversion, like we're working on problems and you need to convert liters into milliliters or milliliters into liters, you could do that. However, you're going to see that often these conversions are within, how do you want to say, other problems, or it's a squared or a cubed label. And in that case, I think you really have to get used to setting up a factor to divide out your units and, make the conversion. You see how our units divide out and we end up with milliliters. So let's definitely practice doing it that way to develop that skill so that we have that skill to call upon when we need it. So in this one, we're going to start with our 3.75 centimeters. Now, I don't know the equality offhand from centimeters to kilometers, but I do know from my metric that I can go from centimeters to meters, and then I can do another step to go from meters to kilometers. On my metric chart, it gives me the equalities. Remember, top and bottom of a factor have to be equal. I know that a kilometer is 1,000 meters. And I know that a centimeter is 1 times 10 to the negative 2, or 0.01 meters. Now I'm in a situation where my units will divide out. If I multiply by 0.01 and I divide by 1,000, I'm going to get 3.75 times 10 to the negative 5th kilometers. And that is the same distance as this. It's just expressed in a different unit. Now you'll get some of those to practice, okay? Here's some others. This would be with those cubed units at the beginning. Now, we're going to do some with cubed units where you have to set up cubed factors. But I want to remind you of something that you know about centimeters cubed that sometimes you're going to be able to use to make things a little easier. We know that a cubic centimeter is the same as a milliliter. They're 1 to 1. So we can use that and set up a factor, and now we can go from milliliters to liters. Because in our metric chart, 1 milliliter is 1/1000th of a liter. So now I have it set up that my cubed unit disappears, milliliters divides out, and I get my answer 0.078 liters. Much the same down here. Anytime you see decimeter cubed, if you need to end up with another cubic unit, I'm going to show you how to do that in a minute. But if you need to end up with something in liters, then you want to use that little piece of knowledge, that little gem from the beginning the fact that 1 decimeter cubed is the same as a liter. See, that allows you to get rid of the cubed unit. And now we go back to going from liters to kiloliters. We had learned in the metric chart 1 kiloliter is 1,000 liters. So now the liters will divide out. So to make this conversion, we're just dividing by 1,000 and we get 4.2 kiloliters. And yes, this step doesn't really do anything to change the number, but what it does is it changes the units. Now, sometimes you will have to solve dimensional analysis problems where you have 2 units that need to be changed. I want to show you how to do that. In this one, the car is traveling 55 miles per hour. So one of the things I want to tell you about is not to do it like this. Do you see how they did /hour? Okay. You're going to get off on a bad foot if you do that. What I would do is always, when it's per something, put it underneath. Okay. And if you want to write a number in, you can. It's 55 miles for every 1 hour. Now you have to convert the speed to meters per second. So both of these labels have to be changed. What I would do is focus on changing one of them at a time. Okay, I'm going to use some factors in red to change the miles into meters. So if we want to change the miles into meters, miles has to be on the bottom. And on that one slide, I gave you an equality that a kilometer is 0.62 miles. We also know then from our metric that 1 kilometer is 1,000 meters, 10 to the third meters. So that has changed my miles and my kilometers into meters. And I can just stop at that point as far as the meters go. So that's exactly what I want on the top in my answer. But now I need a couple of other steps to convert the hours into seconds because I'm trying to get seconds on the bottom. Now, when I do this, since hours is on the bottom at the beginning, I have to put the hours on the top in my factor. Why? So that they will divide out. We know that 1 hour is 60 minutes. And we know that a minute is 60 seconds. So that really wasn't too hard. The big thing here is just remembering that since hours is on the bottom at the beginning, when I set up my factor, hours has to go on top and minutes on the bottom. And that also means in my last factor, minutes has to go on the top and seconds on the bottom. In this one, I would take the 55, divide by the 0.62. You divide by anything that's on the bottom. Multiply by 1,000 since it's on the top. Divide by 60 and divide by 60 again. And with 3 sig figs, I get 24.6 meters per second. And I'm doing 3 sig figs because my speed had 3 sig figs. So that's the equivalent in meters per second. If I was going this fast on 83, I would be doing exactly the speed limit on 83. Now, in other problems, you're going to be dealing with squared units. So here we have that a box of Reynolds wrap is marked 75 feet squared. Okay, so it's 75 square feet of aluminum foil in the box. And what we want is meters squared. Okay, now when you're doing a problem like this, what you want to do is set up the units just like you would if they weren't squared. So I would go from feet to inches, and then I would go from inches. My first random line today. I was doing pretty good. From inches to centimeters. And then since I'm looking for meters, I would go from centimeters to meters for the last one. Now, I've got the basic structure there. You see how the feet will cancel the inches, the centimeters, and the meters. However, okay, all of those factors need to be squared. So since the feet is squared, so that I'd be essentially having feet squared on the bottom and inches squared on the top of this factor. Okay. Now, you still fill your numbers in, like a foot is 12 inches, an inch is 2.54 centimeters, and let's see, a centimeter is 0.01 inches, or excuse me, 0.01 meters. And what you have to do, though, is basically you either have to go through and square these factors first and, like, get numbers. But I think it's most accurate. I just, plug in 75 and then I multiply and I put in parentheses 12 squared and parentheses. Then I multiply by, start another parentheses, 2.54 squared, and then another parentheses to end that, and then multiply by and use a parentheses 0.01 squared and end that. When you do that, you should end up with, oops, I'm on the eraser. You should end up with 6.97 meters squared. So you definitely want to go through and try that on your calculator to make sure that this is what you get. Now, there's other times too where you could have cubed units because it involves the volume of something. Okay. So here we have the density of silver. And we always start with the number we're given, and it's grams per centimeter cubed. So I'm going to put that 1 centimeter cubed, right? I'm going to put that on the bottom. Now, remember, change one factor at a time. So let's change the grams. We know that there's 453.6 grams in a pound. That was part of the info I gave at the beginning. That'll have my grams dividing out and give me the pounds that I want on the top. So I'm done with that. And I do not need to cube that particular factor because the grams is not cubed. But when I do these next several factors, I am going to have to cube these. Why? Because the centimeters is cubed. So I'm trying to end up with feet. So I can go to centimeters to inches. Now notice how I put the centimeters on the top. Since I'm starting with it on the bottom, it goes on the top in the factor. And we know there's 2.54 centimeters in an inch, and I have to cube this. Why? Because over here at the beginning, it is cubed. So I have to cube this, which means I have to either multiply by 2.54 3 times or, cube it when I'm multiplying by that. And then I want to go from inches to feet. I know there's 12 inches in a foot. I'm putting the inches on the top so that it'll divide out. I have to cube this as well because when you cube this factor, you're going to end up with inches cubed on the bottom. So I need inches cubed on the top. And that's good because then I'm going to end up with feet cubed on the bottom, which is exactly what I need. In this one, I'm taking 10.5. I'm dividing by 453.6. But then I'm multiplying by 2.54 cubed, and then I'm also multiplying by 12 cubed. And in the end, I get the answer 655 pounds per cubic foot. And I got another little random line in there. Sorry. Okay. So hopefully this helped. That chart of metric, I'm going to give you a chart like that so that you have it to consult. But if you're at home watching this, I would take a picture of that chart so you have it to consult, and then know that eventually you need to memorize those metric prefixes and how they're related to the base so that you can use them in doing conversions. Okay, so good luck and see me if you have any questions.